Okay, guys, welcome back to yet another episode of DSA Python series. And today we will be talking about linked list. Okay, let's do it. Linked list. Okay, so let me just put some, uh, okay, so linked list. Let me just put that inserting a node. Okay. So yeah, so let's start with the discussion. What is linked list? Okay, what do you mean by linked list? Okay, so we have a head, and uh, we will have this kind of a list where one is linked to two using the address. Okay, two is linked to three using this address, likewise. And in the end, if it if the address is null, then it means that the linked list has ended, right? That's all with the linked list, the concept. Okay. uh, okay, so uh, before understanding what the how we can do the insertion, let us first try to understand what a linked list is. Okay, and how we can create a node, right? How we can create a node, so that we need to understand. Okay, so we will just consider a let's can you draw. Okay, I'll just first do this. Okay, so the topic is linked list, right? Okay, and this is one, this is two, right? This is three, and this is four. Okay, so mm, right. So now what I'll do is I'll try to create a node. Okay, first of all, I'll what is node? I'll just create a node. So So just think of this node. So this is a node. Okay, 7. Okay, so this is a node. This is a node. Okay, this is also a node, right? This is also a node. All these are node, right? Now what I have is, here I will have some value. Okay, I will have some value, and here I will have some address of this node. Okay, this is the address of this node. So let's say if the address is 527, then the here the address has to be 527. Okay, so this is the address and this is the value. Okay, this is the value, right? So this whole arrangement is called as the node, right? Now to create a node in Python, you need to go with creating a class whose name can be a node. Okay, and we will define a function which will take the value of take some value, and we will try to create this node, right? Okay, so in that way we will proceed. Okay, so so I will just say class node. Okay, and here I will define def, just give me some seconds, init. Okay, double, and here I will give self, and here I will give some value. Okay, this will be my function, and with this I will try to give the value as well. And if you see here, right now I have this node. Okay, right now I have this node. Do I have the address? Like, do I have uh, whether this node will correspond to, I mean, this will come after this, or this node will come after this, or this node will come after this? In according to that, this address will change, right? So as of now I don't have any address, so I will take this as the empty. Okay, address will be empty. So I will just say self dot val is equal to val, right? And self dot next. Okay, next means I want this. Okay, so this next is equal to none. Okay, capital none, right? So in this way I will define a node, right? This is the way how you can define a node, right? So if I talk about how you can, how you can append, all right. So let's understand how you can appending the node in singly linked list. Okay, so right now, how you can append? So there is, again, you have to define a function called append, and you will give self and val as the value. Okay, and you, for appending, you just need to have a new node which will be the node of value, right? So you will call that function. Okay, so let us try doing that. Okay, so I will just have class. Okay, class singly linked list, right? Okay, and here I will be giving the uh, I will just have this. Okay, and I will have a function def double underscore init double underscore, and I will give self comma val. Okay, right. And see, initially, so this is basically my head. Okay, so to create or to append a singly linked list, okay, you need to understand, or you need to have an idea of where the head is. Head means the first node. Okay, that is called the head. Okay, so you need to create that head first. Okay, you need to create the head first. So you just have to uh, create self dot head is equal to, as of now it is none, right? It is none, right? So uh, so this will be here. Okay, so in the def function it will be like this. Okay, yeah. Okay, now what I'll do, I'll create a function append, which will again give, which will again have the uh, parameters as val. Okay, so I will just have def def I will give a function append. Okay, which will have the parameter self comma val, right? So this value I have to append. Okay, so what will be my new node? Simply my new node will be node of val, right? So new underscore node. Okay, because this node I have to append. Okay, so what I have to append? Node of val, right? This I have to append. Now I will take consider a condition. If my self dot head is equal to none, then my self dot head will be equal to my new node. So what I'm doing is I want to create my self dot head or the head as my new node, right? So if self dot head is equal to none, so what I'll do, I'll just do self dot head is equal to new node, right? It will have this new node. Okay, it means that node of val. Else, so it will have, I will just say I will take a current. Okay, so my current will be equal to self dot head. It will be equal to self dot head, and I will take a condition that the next node of the current should not be none. Okay, if it is not none, then I will do current is equal to current dot next. So while current dot next is not none, right? Is not none. So what I'll do, current dot next is not none. It means that current will be equal to current dot next, right? It will be equal to current. And my current dot next will always be equal to my new node. Okay, so this current dot next will be equal to my new node. So this is how it will get appended, right? So current equals self dot head. So we will start a while loop where in current dot next is not none. So if this condition, within this condition we will have current is equal to current dot next, it becomes current dot next, and current dot next will be equal to my new node, right? So that is how a singly linked list will be created. Okay. So let's do some question from Neat Code 250. Okay. Uh, so let's do valid palindrome 2. So valid palindrome 2. So given a string s, return true if s can be palindrome after deleting at most one character from. So what do we have to do is, um, we have a string given and we have to return true if s can be palindrome after deleting at most one character from it. At most one means you have to delete one or zero, right? If you don't have to remove any character and if it is like palindrome, then you need to return s, or at least you need to return only one character to make it a palindrome, right? So that's the, so you have first example aba, so you don't have to remove any character, so it is true, right? So what is palindrome? You read from left or you read from right, you get the same characters, okay, you get the same string, then it means that it's a palindrome, right? Now the second example is s equals abca. Okay. Now if you remove c, if you remove c here, okay, then you get a valid palindrome, right? So your answer should be true. Okay. Although abca is not a palindrome, but if you are removing c from it, then you get a valid palindrome, right? So that's, and if the input is a b c, then in any case it is false. You cannot create a valid palindrome, right? So what idea is coming to my mind is, first we will check whether the this thing is palindrome or not. To check it as palindrome or not, we can use two pointer approach. um, we can reverse the string and try to compare. Like we can reverse the string and save it in any other string, and we can check. Or it's better to use two pointer approach, because I'll put one I at A and I'll put J at the last. Okay. Mm. So let's consider this string, and so this is my string, and this will be my I, and this will be my J. Okay. So if I move my J and I, so nums of I equal to nums of J, then I'll shift, right? I'm sorry. Then I'll shift. Okay. Now I will be at B. So if they are equal, then they will move, right? So what I'll do is, while I less than J, yes, I less than J. Um, if nums of I is equal to nums of J, then I plus equals 1, J plus equals 1. Else, if they are not equal, let's say here B and C, and let me just put some more character here. So if, let's say I have this, let us consider I have A, B, C, D, C, B, A, B, C, D, E, D, D, C, B, A. So this is a palindrome. If I put, let's say I put X here. Okay. So here is my I. Okay. So sorry, I'm so sorry. Here is my I. Okay. At 0th position, and I have my J at n minus 1 index. So nums of I equal to nums of J, it will move. So J will move, and similarly I will also move. Then again B equal hai, then it will move, and J will also move. Now nums of J is X and nums of I is C. All right. So they are not equal. It means that uh, else if nums of I, so j minus equals 1, okay, and here j minus equals 1. So if nums of I equals, then we will move both. Else we will check whether after deleting one character, are we getting a palindrome? So can we define another function palindrome so that we can directly check? That will be a good idea. So if we define another def function is palindrome, then in else statement we can directly check whether it's palindrome or not after deleting one character. So that we can think of on those lines. So So I'll define a palindrome, okay, where I will give left, right, and the string, okay, and if left is not equal to right, I'll just return false, and I will just increase left and decrease right. That's it. So let's do on those lines. Def I will give the s comma right comma left, okay, and left is rather than right. What I'll do is if s of left is not equal to s of right, okay, return false, or it will be left plus equals 1, right minus equals 1, and here return true. And this is a palindrome. Like if some word is a palindrome, then it will return us true and false. This we will put in the, here in this function. Okay, let's try to do that. So what I'll do is in else statement, I have a function which can check whether the word is palindrome or not, right? So ABCA, what I'll do is ABCD DC. Okay, so when this comes here, uh, so I will just so I will just say uh, return is palindrome, and self dot is palindrome. This function I have to call in some other def function, then I have to palindrome. Here I will uh, give s comma, so it will check palindrome if, let's say, my I will just say I plus 1 and j, or right, or I have to increase or I have to increase j plus 1, right? Or j minus 1, sorry, right? J minus 1. So I have to increase here. I just have to increase this once this is not equal, right? X, and here is coming C. So what I'll do is I'll first check with when I increase the I, whether it is coming or not. So if it is not coming, so this is not valid, right? Now I will check is palindrome when I have j minus 1. It means that I is again here, and I will just say j minus 1. So now it will check. So j minus 1 is also C. Nums of j minus 1 is C. And here nums of I, and here nums of j, right? Nums of j. So both are C. Now it means that this is valid. I will just say self dot is palindrome, right? Once this is checked, um, so what it will return? It will return this. It will return this because this is getting satisfied here. So now I will just do I plus equals 1 and j minus equals 1. I think this should work. Not necessarily the value. Okay. So initially I have to put I is equal to 0 and j is equal to len of s minus 1, right? Nums s of I. So case 2 is coming true. A, B, A. Can you do like this? Because always we have to increment I plus equals 1 and j plus equal j minus equals 1. So while I is less than j, if s of I is not equal to s of j, I'll just have to return uh, this function, that I'll just increase the ith dimension and I'll check, and I'll just be returning it. Okay, so here I'll just return true. Yes. Yes. Okay, so this was the problem. So guys, I think this was not an easy problem. It was a medium level problem where we we were required to call a function If you are doing it for the first time, this might not click into your mind, but yeah, you can look at the hints. So there are similar question, valid palindrome 2. So these are locked. So people are saying there is more. I think this is more of medium. So don't be discouraged. Yes. Okay. It should be medium. You can just submit it. So this gives us the valid palindrome. All the test cases are passed. Now let's talk about time complexity. So here you have one while loop. So here again one while loop. So total time complexity will be order of 2n. And here we are. If I put else here, then doesn't make any difference. Okay. Let's try this again. Valid palindrome. Okay, so guys, let's do this question valid palindrome in the next class, right? Okay, till then, bye bye and good night.